So we come to chapter 6. Now we come to chapter 6. Analysis of structures. Now, after in chapter 4 and in chapter 4 we usually work at support forces. We want to determine support forces. Now in chapter 6, we want to determine more things. We want to determine the forces in structure. We want to determine the forces in structures. To begin with, and we are working on trusses. The first kind of structures we want to work on is trusses. Trusses are like this, or like those bridges. Let me have a look. And trusses. Oh. Trusses are like these, the bridges that you may see at various places. Now you may think that we are mechanical engineers, we are not civil engineers. So why are we studying trusses? Now let's come to this problem, and this is a part in A380, and we want to make this part not that heavy. We want to reduce the weight of this part, and the computer tells us that the part should look like this. And you can see the structure is like this, and it is actually looks like a truss. Okay, this looks like the one. It looks like the one here. Oh, sorry. It looks like the one here. It's okay. Although it looks like a bridge, but in many structures on airplanes or in the new structures that we have structures like this. Now, before we work on the mathematics, and we have let's define what are trusses. Let's talk about this. And this is a truss. The whole thing is called a truss. Okay, and for each one is called a member of a truss. For these rods, and each one is called one member and two members and three members. And the whole thing is called a truss. Okay. Now, for the next point, and so how do we define trusses? The first one is members are straight. Members are straight and connected to others at the ends only. That means For example, and for this member, so the ends of the ends are points A and point C. So it is one this member is connected to other bodies at points A and point C only. Okay? So all the other forces can only act on points A and point C. These forces can only act on points A and point C, and there are no forces in the middle. There are no forces in between. So these members can be called, what can these be called? So we have learned 2 force body and 3 force body. So are these 2 force body or 3 force bodies? 2. Okay, so all the external forces only act on point A or point C. And for this one, forces only act on point C and point E. It's okay. So these are 2 force bodies. That's the first thing. The second thing is members do not go through joints because you may ask me, okay, we have a member ADE here. We have a member ADE, it is straight, and it has joints at point D, and point E is then a 3 force body. The answer is no. In trusses, we don't count ADE as one member. We count AD as one member and DE as another member. It's okay. So we don't have ADE as one member. AD and DE are 2 members. It's okay. Oh, sorry. Right, thank you. Yeah, thank you. So ADP is, there are 2 members. Okay, AD is one and DB is another one. It's okay. And the third thing is all external loads act on joints. So if we have a force, external force P, it acts on a joint. So we don't have this, okay? We only have forces acting on joints. Now, and the next one is all joints are pinned. What means by a pin joint and what means by not a pin joint? Okay, for a pin joint, it means, let's say this is fixed and we have a pin joint here. It means this one can rotate, right? In chapter 4, we say a pin joint is that there is a rotation between the 2. So for this pin joint, DAB, that they can rotate, relative to each other. But they cannot move, this one, DA and AB, AB cannot go to the right, and cannot go to the right while this is fixed. So if they move, they should move together. Okay? If they move to the upwards and downwards, to the left and to the right, then they should move together. But for rotation, that they can have relative rotation. The last thing is that if we have heavy members, if we have heavy members in this truss, for example, this one is like say 500 kilogram. For example, if it has if the let's say 500 Newton, 500 Newton is better. 500 Newton here. If the weight of the member CB is 500 Newton, how should we draw it on the three-quarter diagram? Because we say that we cannot have we don't have external forces acting at the middle, right? We don't have external forces acting at the middle. So it means 500 newtons here is not okay. So what do? What we work on is here. It's like this. We put 250 newtons here and 250 newton on B. So it's always is applied to the joints and half of them on each joint. Okay. Now for now we go to the next next notes, and in the notes that we have something called simple trusses, and simple trusses are trusses that rigid bodies if supports are removed. So, and for example, this one is a rigid body without the supports. That means it is a simple truss. But this one is not a simple truss. Okay. For this for the truss on the bottom right hand corner, that if we remove the supports, these two parts can rotate, right? Because the joint FB is a hinge joint. So if the supports are removed, ACB and BEF can rotate relative to each other. So it is not a simple truss. Now we move on to one more thing. Now this is a simple truss, right? And we have three members, 1, 2, and 3. We have for this truss we have 3 members, right? And we have 3 joints, and for example A, B, and C. A, B, and C. So we have 3 members, right? Number of joints is 10. So how many members do we have? Now we have 3 members, and we have 3 joints. Now we have three members and we have three joints. And now we have, say we have one more joint here, for example, joint D here. So if we want to fix this point D, how many members should we add? How many members should we add to keep it fixed? 2. Very good. So we have we add one member. So we add one member here and one member here. So if we have 4 joints, then we will have 5 members. Now, if we have one more joint here, and we need to have 2 more members to fix it, right? So if we have 5 joints, then we will have 7 members. Okay. M means number of members. How many members do we have a trust? So 这两个是数字，跟我们都撇开了多少而已。So we have we now have we can have a relationship that m is equal to 2n minus 3. Of course, if you by your high school mathematics, then if you have some m and we have some n, and it has a relationship, you can find this, right? And I think you at high school you have y equals to x plus c, this kind of thing, and you can look it up. Now, and what happens if we have too many members? What can happen if we have too many members? For example, for this trust. Let me mark points A, B, and C here. Let me mark points A, B, and C here. Now, and suppose we have, let's say we have an external force F is acting on point B in this direction. If you have force F acting on this direction, so does this force going to compress member AB, or it will pull member BC? Actually, we don't know. If we put a force F, and a force F on point B, so of course it will press member AB and it will extend. It will have tension on member BC, but what's the ratio? What's the ratio of these two parts? We don't know. So in this case, let's count the number of members and joints here. Here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 members, and we have 5 joints. And M is larger than 2 M minus 3. The ratios. Therefore, in this case, we say the truss is statically indeterminate. It means we cannot determine the forces in all vectors. Okay. Because we don't know the rate, we cannot determine the ratio between the forces in AB and BC. Okay. Now, and for trusses, and we have a. So if you finish writing this and go to the next page. We have a 2-step approach to analyze trusses. Okay? Now, this. Now, let me go to the next page. If you want me to come back at the end of the lecture, come to me. Okay. Now, and so to analyze trusses, now we have and this is we have an SOP. We have an SOP for hand calculation. But for if you use a computer to do calculations, we have another SOP. But this, of course, in examination we will have hand calculation. So we have this SOP. We have 2-step SOP here. Step 1 is here, and step 2 is here. Now, for the first step, which is identical to chapter 4. So we assume the whole structure as a rigid body, and we determine the support forces. Now, and in this problem, we have points A, B, C, and D. So what is the what is the type of support at point A? And what is the support type at point B? That's the first question. So at point A, we have something, this thing is fixed to the ground. So point A and point A, can it move to the left or to the right? No. Can it move up or down? No. And can it rotate? Seems so, because this is only a pin. So this is a pin joint. And it has a force in x direction and in y direction, which are a x and r a x and r a. Sorry, what r a y and r a x. And on the right hand side, which type of joint do we have? What type of joint do we have? We have a roller joint. So it cannot go up and down, but it is not fixed to the ground, so it can move to the left or to the right. It can move left and right. Of course, it cannot move up and down. It can move left and right. So we only have one force going up. It's okay. So this is not chapter 6, this is the things from chapter 4. I think we can do this. Now after you get this right, you in your free body diagram you have this, and then we have the typical free equations and summation fx equal to 0, summation fy equal to 0, and summation n equal to 0. It's okay. So this is the first step. Now we come to the second step. We cut the whole truss into two rigid bodies. Rigid body 1 is here. And rigid body 2 is this one. Let me slide it. Rigid body 1 is the whole structure minus member AB, and rigid body 2 is this part. We take this out and to be the rigid body 2. It's okay. Now, and if I have one rigid body like ABCD here, and we apply a force on point P, what will happen? We have a truss here, and we have a pin joints. Remember, this joint is pin. Point C is pin. So if we have if we apply a force at point P, what will happen? It will go down, right? It will go down. So if we do nothing, the whole rigid body will look like this, right? Right? If we do nothing. So what should we do now? After we apply the force P on the original structure, it does not fall down. So from here, how should we go back to here? We can put on two forces here, right? We'll put two forces here and such that it can come back together, like here. So to go back to the original shape, we add two forces here. So we add two forces here. And then we go back to the original shape. So we have, it means these two. It's okay. If we do nothing, it will go down. The shape will become like this, right? But if we put two forces here, and then it will pull back together. It's okay. Now, we come to high school physics again. So we have action and reaction. Because originally we have this bar here. So if we have one force acting on point D to the left, it means we have one force acting on rigid body 2 to the right. It's okay. If we have one force acting to the right on point A, it means we have a force acting to the left on rigid body 2. It's okay. This one is going to here. So what are these forces in physics? Actually, these two, what are the physical meaning of these two forces? These are the tension of member AD. Okay, so we mark it as TAD. Let me simplify it and we don't put all the symbol here. And we have TAD here. And of course, action and reaction are of same magnitude, so we have TAD here and TAD here. So this is our first step. The first thing we do is step 2. I will continue on Thursday on finishing this question and do an example. Okay.